Okay, piecewise defined functions, graphing just simple lines here, but then they're going to get a little bit more challenging. Okay, number one, go ahead and copy this in. Go ahead and graph f of x is equal to 5. And I don't want to see the whole line. I just want to see this much of it, this piece of it. That's why they're called piecewise defined functions. But we got to know how to do simple lines. If we can't even handle the lines, you got no chance later when we get to the parabolas and absolute value functions and the square root functions and some other ones. Okay. All right, so what is this? What is this right? How do you graph this? This is just a line. This is the line what? This is a line. And what is that? What is that line? That line is what? Y is equal to 5. Remember, f of x is y. Y is equal to 5. Y is equal to 5, and do this with a pencil because you're going to have to erase. Y is equal to 5 is... Well, it's a horizontal line. Go to y, go to positive 5, and it is a line that is, again, with a pencil, because some of this is going to get what? Erased. It is a continuous line like this, but we're only gonna want to see this at this certain interval here, or this inequality, right? So what is the critical point that you have to go to? What do you have to do? What is this telling you? This is telling me that x negative 2, x negative 2 is a critical point. It's an end point. So I'm going to go to x, I'm going to go to, negative 2, right here. And I'm going to go up to the line. Does everybody agree it's right here? Okay, put a circle right there. And how do you know when it's an open circle or it's a filled-in circle? If it's inclusive or exclusive, right, includes it. Has an equal sign, so yes, it is going to include the negative 2. Now the question here is, do I keep the right part of this graph and erase this left side, or do I keep the left side and erase the right side? Well, you have to know how to read this. This is saying I want the values of x that are negative 2, right, because of the equal sign, and anything and all numbers on x that is less than negative 2. Negative 2, negative 3, negative 4, negative 5, negative 6. I only want to see this side. Everybody got that? Mm-hmm. So we have to erase this right part over here? Yeah. Well, this you should already been able to do because that was the last assignment. Yeah? So we're warming up. Okay, and this is number 1. So put a number 1 right here. This is the graph for this first one here. I'm going to do another one. We're good with that? Now, here's the difficult part. Right now, we're taking notes. We're doing it on paper with a pencil, and you're able to draw the whole line, and you're able to erase stuff. On the next assignment that's going to be on Delta Math, you can't do that. You can't graph the whole line and then erase it. It doesn't let you do that. So it's a little bit tricky, but you have to understand how you're doing it here to be able to do it on Delta Math. So pay attention. Number 2 is going to be f of x is equal to negative 4, another simple line to graph. But what if the domain is this? Well, on number 2, what do we have here? Huh?
All numbers between those, including 3.
Well, we gotta graph the line first, yeah? Is this a simple line for us to graph? Yeah. What line is this, everybody? This is y is equal to negative 4. This is the line y is equal to negative 4. Well, I'll graph that line first. So you got to see that line first. Again, when you do this on Delta Math, you're not going to be able to do the whole line. But right now, we have a pencil and eraser and all that. Go to y, go to negative 4. It's another horizontal line right there, isn't it? Go ahead, trace it lightly. And then we're going to erase some part of it or something. I don't know. We'll see. Okay. Yeah? What is this? What is this, everybody? That's where I only want to see this line. I don't want to see the whole thing to the right, all to the left. What is this saying? I got to go to x negative 5, go to negative 5 on the x, draw a circle right there. And then I also have to be, another one over here on this side is 3. So go to 3, go down to the line right there. You guys agree with that?
No.
No, you don't agree with that.
Includes 3.
Oh yeah, we're getting there. We're getting there. And yeah, this one does have the equal sign on the 3. So everybody, yeah, we do fill this one in. Thank you, Jasmine. Everybody good? So which part of this do we keep? Do we erase the middle and keep the arrows on the left, right, or?
You keep everything but the middle.
What is this?
You only keep the middle.
This is saying that x is a number that is greater than negative 5, but less than 3. So isn't it this middle part? Yeah. So that means we erase. Okay, are we good? Yeah, we've seen this before. This is really not new material, but the graphing part is. Are we okay with graphing that? Yeah. Okay, this is number 2. So it's number 2. Put a number 2 right here. Here's the one that's going to get you. Number 3. Number 3. Are we done with 2? Everybody good? Number 3. What about this one? Oh yeah, here comes the real test. Let's see. F of x is equal to 2 over 3x plus 3. And I only want to see this. Okay, go ahead. I'll give you 1 minute to graph that line. This is a line, but not a simple line like this, like numbers 1 and 2. This is what? Y is equal to 2/3 x. This line has a slope and a y-intercept. Does anybody remember that? A slope and a y-intercept? Yes. This one is your slope. This one is your y-intercept. And I gave you 2-3 minutes to figure it out, and only 3 people could do it. So I'm just going to do it. Here it goes, just to remind you. I'm sure once I go over 1 or 2 of these, you're going to be fine. You start with the y-intercept. You start with positive 3 on the y-axis. The y-intercept is positive 3. Put a point right there on positive 3 on the y-intercept, right here. This line is going to cross the y-axis at positive 3. And then we're going to apply the slope. Does anybody remember the slope? Since the slope is 2 over 3, the 2 is rise, the numerator is rise, and the bottom is what?
Run.
Oh, now you know something? It's rise over run. But rise over run starting from this point, starting from the y-intercept. Yeah? Who can tell me what to do right here? Do I rise or do I run first? Rise. You're going to rise 2, up 2, and then what? 3 to the right. 1, 2, 3. Boom. That's another point that's on this line. And guess what you're going to continue to do? Rise over run to find additional points. You're going to rise 2 and run what? 3. You're going to rise 2 and run 3. And when you run out of room this way, kind of think of this like a little stair, like steps, like up and across, up and across. You don't have to draw them. I'm just going to draw. Everybody see how they're consistent? If you're off by 1, it's going to start being crooked. Everybody see how it makes like little steps? Yeah? Now, how would you find the points down here? Some people are like, yeah, I can go this way, but I can't go this way. How would you find additional points? Yeah, don't start another pattern. Do not start a different pattern down 2 over 3. No, follow the same pattern. So now I'm going from this point to this point. Left 3, down 2. Yeah? Left 3, down 2. Left 3, down 2. You're going to tell me you don't know how to go the other way? Left 3, down 2. Left 3, down 2. Left 3, down 2. And you will find additional points on this line. Additional coordinates on this line. If you remember from geometry, these are collinear points. Collinear points are points that are in the path of a straight line. This is how you graph a line. You start with the y-intercept, which is here 3, and then you apply the what? Slope to find what? Additional points on that line. Oh, okay. Are we remembering now? Yes. Okay. Go ahead and graph the whole line lightly. Right? It's continuous. There's more points if we had more graph here. So it goes infinitely down that way and it goes infinitely up this way. But I don't want to see the whole line. Now what do I look at? What do I do now, guys? I look at this. I look at this. Go ahead and let me see you do it. You tell me what you need to do to know which part of this line you need to erase and which part do you keep and where's the end point. Where is the end point? That's the critical point. You got it, Giovanna? Let me look around. Okay. So this, see, don't look at the inequality yet. Just go to x and go to 6. Go to x and go to 6. Here's x, here's 6, and then what I do from there, everybody, I go up to wherever the graph is. Everybody agree it's right here? Yep. This is the critical endpoint right here at 6, 7, right? But right here where x is equal to 6, is it going to be an open circle or a filled-in circle? Open. See, it doesn't have the equal sign. Some of you forgot that. And then what does it say? I want to see from 6 and which values of x? The values of x greater this way or less this way? Okay, so that means I keep the left side and I erase the right and the top. Yeah. So easy when you know how to do something. You understand it. Okay, do not lose this paper. We're going to do more problems tomorrow, more like this. But I will put this in on the video.